Colleagues, good day to everyone, morning, afternoon, evening, and a very welcome to this session on ultra-high energy cosmic rays. Today, our speaker will be Silvia Mollerach from Centro Atómico Bariloche in Argentina. So, Silvia, welcome.
Hello, can you hear me and Siri?
Yes, okay, you have 25 minutes, so floor is yours. Go ahead.
Thank you very much. So first, thanks a lot for the organizer for the invitation to talk here about ultra-high energy cosmic rays. Let us start by having a look to the spectrum of cosmic particles that extend from 10 to the 9 to 10 to the 20 eV. We see that the overall spectrum falls like e to the -3, the main features being the Ni, a steepening of the spectrum at few times to the 15 eV, and the angle, a hardening of the spectrum at few times to the 18 eV, and a sharp fall-off at 10 to the 20. So at the lowest energies, where the flux is high, cosmic ray can be detected from space, as we have heard a very complete review this morning, where not only the energy, but also the charge and the mass of the particles can be measured. When we go to higher energies and lower fluxes, this is no longer possible, and we can detect cosmic rays only through the extensive shower of secondary particles that they develop in the atmosphere. And there are several observatories performing these observations from the ground. At the lowest energies, we know that cosmic rays are from galactic origin, while at the highest energies are from extragalactic origin, and it is not yet very clear where the transition happens. So the main question that we would like to answer about these particles is where and how they are accelerated, and how is their propagation to the Earth. We have to take into account that charged particles interact with the medium while they travel and are also reflected by the magnetic fields. Photons can travel straight, but they are also attenuated during their trip, while only neutrinos come unattenuated and in a straight trajectory. So at the lowest energies, we have heard several talks in this conference showing the impressive measurements that have been performed of the spectrum of the individual nuclei, especially many talks from the AMS detector. When we go to highest energies, this with the indirect measurement of the air showers is no longer possible, and we can only divide the particles in rather broad mass groups. So this is what we can do for the end of the galactic spectrum and for extragalactic cosmic rays. It is a common idea that the end of the galactic proton spectrum happens at the Ni feature at few PV, and that the end of the iron galactic component happens at another feature in the spectrum that is called the second Ni, happening at around 10 to the 17 eV. We can see here in the data from the Cascade Grande that is divided in the heavy and the light components, the second Ni appearing clearly here. while the light component shows hardening in the spectrum that could be probably related to the starting of the extragalactic component. So for the rest of the talk, I will especially will be talking about this highest energy piece of the spectrum of cosmic rays, of which the two main observatories in operation are the Piero Observatory in Mendoza, Argentina, and the telescope array in Utah. This is a large array of surface detectors. The Piero Observatory covers 3,000 square kilometers, and they are water Cherenkov detectors. And the array is overlooked by a fluorescent detector telescope that can detect the fluorescence ultraviolet light that is produced in the atmosphere by excitation of the nitrogen molecules when the shower of secondary particles traverse the atmosphere. And also in a small piece of the array, there are underground muon detectors and radio antennas. The telescope array is an array of scintillators covering 700 square kilometers and also overlooked by fluorescence detectors. We have heard a very complete review of it by Doug Berman on Tuesday. So how do these hybrid observatories work? During a moonless night, when a fluorescent detector can operate with a duty cycle of about 15%, the fluorescent detector registers the energy deposited in the atmosphere as a function of the atmospheric depth. And then by integrating the signal, a calorimetric estimation of the energy is obtained, and also the point of the atmospheric depth where the shower reached the maximum is used as an estimator for the mass of the primary particle. Meanwhile, the surface detector sample the signal at different distances from the shower axis, and by estimating the amount of signal at the reference distance at for Rocher is 1,000 meters from the shower core, an estimator of the energy is obtained with the 100% duty cycle. And this energy can be calibrated with those that measured by the fluorescent detector for the subset of the event registered by both observatories, both detectors. So going now to the main results obtained, we can see here a very precise measurement of the energy spectrum by both observatories. We can see very clearly the second need, the angle, the final suppression of the spectrum. Also, a low energy angle appears at about 3 times to the 16 electron volt. And then this newly observed feature called the instep, that is softening of the spectrum that appear at 14 eV. Here are more or less the same features measured by telescope array, where we can also nicely see the knee here. Going now to the measurement of the mass composition, the most widely used indicator is the depth of the atmosphere at which the showers reach the maximum. This is because heavy nuclei shower develop higher in the atmosphere and have smaller fluctuations, what can be understood as the superposition of a smaller shower initiated by the nucleons. So you see here which are the predictions for proton primaries and for iron primaries, for the mean X max and for the fluctuations. And what we see is that observation indicates that the composition is becoming lighter up to an energy of 2 ex-electron volts, and then heavier at higher energies. When we want to make a contact of this measurement of spectrum and composition on Earth with what those of the particles at the surface accelerated them, we have to take into account that during the trip to the Earth, the particles will be interacting with the radiation backgrounds like the CMB and the extragalactic background light. And those particles will lose energy and also can change composition. The main processes being pair production, photodisintegration of nuclei, and photopion production. And we see here that at the highest observed energies, for example, helium cannot arrive from farther than just few megaparsecs, and even proton or iron nuclei cannot come from much farther than 100 megaparsecs. So if we want to make an interpretation of the spectrum and composition data, making through a simple model of homogeneously distributed sources that can accelerate particles in a rigidity-dependent way, with which we here model by a power law with an exponential cutoff. What we see is that to explain the observed spectrum and composition above the ankle, we need a succession of a different mass group, each time heavier. Here we see the helium, here the CNO group, and here iron-like group that contribute, give the main contribution to the spectrum in a rather narrow energy band. And with this kind of contribution, we can correctly explain the observed spectrum and also the composition becoming heavier. And also the small fluctuations in the X max observed due to the fact that the different components do not overlap much in this region. If we also want to explain spectrum and composition below the ankle, we see that we need lighter component with softer spectrum. So putting both things together, we need like two population of sources, this high energy one that have a mixed composition of intermediate to heavy nuclei, and a lower energy one with much softer spectrum and lighter composition. These are the energy spectrum of particles at the surface, while after propagating to the Earth, they describe very well the observed spectrum. In this case, the final steepening of the spectrum observed results from a combination of propagation and maximum rigidity of the particles accelerated at the sources. So going now to the physics of the air showers. Air showers have essentially two components, the electromagnetic one that comes from the decay of neutral pions, and that takes the major part of the energy in the shower, and as we have just seen, is that that gives determination of the composition of the shower through the fluorescence detector measurements. The other component is the muonic one that comes from the decay of charged pions, essentially, and it has a subdominant piece of the energy of the showers, but also has some information on the composition of the primaries, and a good description of the shower developments should describe consistently both pieces. So, as we already said, the electromagnetic piece is well sampled with the fluorescence detector, and we have a measurement through the X-max. But we can also observe the muon component of the showers in two different ways in Auger. One is using very inclined showers that has the electromagnetic part being attenuated while crossing the atmosphere. And this can be done at the highest energies. And also we can measure the muon component using the underground muon detector that is used at smaller energies. So what we can see in these plots here are also the expectation from the Monte Carlo simulation of extended air shower with different hadronic interaction models and for different primary composition. And what we see is that all the models predict a muon density at ground smaller than what is observed for the composition determined through the fluorescent detector. So there is a problem in this modeling of the extended air showers that is complemented by this measurement that when we, in the set of the inclined hybrid events, we measure the relative fluctuations in the number of muon. They look in agreement with the expectations of this gray band here that correspond to the expectations of the measured composition. So this fact is indicative that the muon deficit originates from small deviations of the prediction of the hadronic interaction models all along the showers and not just in the first few interactions. So this is an open issue that needs to be studied and solved. Going now to the arrival direction measurements, starting from large angular scale ones. Auger has measured a few years ago at energies above 80 eV, a significant dipolar distribution in the arrival directions that with the new data it is at the significance of 6.6 sigma. The dipole has an amplitude of around 7% and points around this direction here, that it's at 115 degrees from the galactic center, so it is evidence of the extragalactic origin of the particles. And if we look at it with more detail, separating in different energy bands, we see that there is evidence that the amplitude of the dipole is increasing with energy. And this, in fact, is in agreement with the predictions of models with a mixed mass composition, as the one I showed in the interpretation of the spectrum and composition. If we look at the direction where the different energy beams point, they are all very close to the outer spiral arm of our galaxy. And this is very interesting to notice that if we have a dipolar distribution outside the halo of our galaxy and we propagate it through the galactic magnetic field, here using the model by Janssens and Farrar, we see that it is moved towards the direction of the spiral arms. So about the origin of the dipole, we know that it can not come just from the Compton-Getting effect, that is the motion of the observer with respect to a frame where it is the cosmic rays are isotropic. This would be an order of magnitude smaller. It can arise from the inhomogeneous distribution of nearby galaxies, as in this model here. Also, diffusion propagation from closest stars can give rise to this kind of anisotropy. So it is still open, the question. The dipolar anisotropy has also been analyzed in the northern hemisphere, analyzing the right ascension distribution, that is a measure of the spectrum in the direction orthogonal to the rotation axis of the Earth. Auger measured this component to be about 6%. The measurement of telescope array is compatible with it. And full sky analysis combining data from both observatories after calibrating the energy, what is done by making match the flux observed in the common declination band where both observatories can see the sky. We can translate the measured energy of one observatory to the other, and this is the map that we obtain, and the dipole is compatible with that measured by Auger alone. We can also extend to lower energies the right ascension measurement, and here we can see how the Auger results compare with Cascade Grande, iSTOP, and IceCube. And what we see is that the amplitude is growing from 10 to the minus 3 to 10%. In this energy range, and we also observed an interesting transition from the phases in right ascension that at low energy point toward the direction of the galactic center to nearly the opposite direction. Going to highest energies and smaller angular scales, the largest excess of flux of Auger appear here. Here is that of telescope array, and at different energies, this is 40 eV, 57 eV. We can look in
few minutes.
Okay. We can look in more detail which objects could be given rise to the excesses. In the Auger region, the radio galaxy Cna is one of the most prominent one. And the observed excess around that direction at energies above 40 eV has a significance of 4 sigma. But there are also other objects like starburst galaxies. So we have also performed analysis fitting the flags expected for different catalogs that represents all galaxies, starburst galaxies, or different type of galactic nuclei. And we have found that all of them show excesses in the region of 40 eV. The most prominent one is that from starburst galaxies with 4 sigma. Well, very quickly, similar analysis combining the data from Auger and TA and comparing to catalogs of all galaxies and starbursts has also showed the largest excess for the starburst with 4.2 sigmas. So in all, the anisotropies tell us that we have a significant dipolar anisotropy and hints of intermediate angular scale excess is at 40 eV and no evidence of small scale anisotropy. So all this is telling us that the deflections in the galactic and intergalactic magnetic fields are significant. And as we don't know the galactic and extragalactic magnetic field very well, and also we don't know the composition of the individual cosmic rays, this is really a problem because we have some candidate sources, but we cannot identify really which are the real ones. So to solve this, one idea is to look for a neutral search messenger like photons and neutrinos that we can distinguish through the different signal they produce from the hadronic showers, but we have seen none of them. These are the bounds, the upper bounds put by Auger and TA on the flux of photons, and there are also limits on the flux of neutrinos. We can see much more detail in the contribution by Gonzalo Parente. And also we have made searches of neutral messengers in coincidence with transient sources and find out. You can see the details in the contribution by Philippe Rouel.
Silvia, I'm very sorry, but okay. I appreciate if you can go through conclusions. We need to close the...
Okay, okay, sorry. So, I will flash this in the near future. Both observatories are being upgraded. Auger is putting scintillators and radio antennas to be sensitive to the mass composition for all the events. And telescope array is improving the coverage for making it 4 times bigger. So we are looking for the new data to answer the final questions. Thanks a lot.
Okay, Silvia, thank you. Thank you very much. So please, any question, go through the chat. In the meantime, Silvia, that we get some questions, I have a very general one related to your last transparency, to your last slide. About the upgrades of the PROJ. Can you update very briefly us about the science case you will improve with the upgrade?
Well, the main idea is to be able to infer the composition using only the surface detector, that is with a 100% duty cycle. So this would be very important, for example, to be able to make an isotropies analysis using the different composition, light and heavy element, and see how are they distributed in the sky, and also to have a much better understanding of the air shower physics.
Okay, thank you. So no more questions, Silvia. Thank you. Thank you very much.
Okay, sorry for the delay.
Bye-bye. Please, everyone stay in the same link, and we continue now with a panel on diversity chaired by Ines. So Ines, are you there?
Yeah, thanks a lot.
Floor is yours. Thank you. Thank you very much.
Thank you very much. Let me share my slides. I assume that you are seeing that. So thanks a lot. Welcome to our TAUP 2021 Diversity and Inclusion panel. My name is Ines Gil Botella. I'm a scientist working at CIEMAT in Madrid, Spain. It is really a pleasure to have and share with you for the first time in TAUP conference series a panel about diversity and inclusion in astroparticle physics in the plenary program of this conference. Many efforts on diversity and inclusion are currently being developed in our research institutions, experiments, countries, and communities all around the world. So with this panel, we'd like to bring you the opportunity to share and discuss with you about these crucial topics from different perspectives. I would like to really thank the TAUP organizing committee for their support in organizing this panel, and especially the co-chairs of the TAUP 2021 conference, Mariam Tortola and Sergio Pastor, for their strong commitment to these topics and have been possible prepare this initiative. And of course, I need to thank our panelists for having accepted being part of this panel and share their experiences with all of us. They actually cover a wide range of research topics, as you will see, experiments and theory, geographical regions, gender, age, etc. So before introducing them, let me explain briefly the structure of this panel for this hour. So we will start with a short presentation of the panelists by themselves. And then we will go through a discussion among the panelists on 4 questions that we have previously agreed, and I will show you later. And after this discussion on the questions, we will give some time to have an open discussion with questions and comments from the audience, from all of you. So please, if you would like to participate and make any comment or question, address any question to our panel, please use the question and answer chat. And I will take your comments and we will discuss about that. And finally, we will close the panel with final remarks from our panelists. So hoping that you will enjoy really the discussion. Let's go directly to the presentations of our panelists in alphabetical order, starting with Summer.
Hi, yeah, I'm Summer. My pronouns are she, her, and I'm currently sitting in Berlin, Germany, where I work at DESY as a staff scientist on the IceCube experiment. I spend most of my time measuring neutrino properties, but I also do quite a lot of work in equity, diversity, and inclusion within the IceCube group here at DESY and also in the wider Berlin area. And I sort of tend to focus on two things in sort of all of these areas that I'm doing this work. The first thing that I focus on doing is creating spaces where people feel safe in fully expressing themselves so that we can start to really celebrate diversity and not just focus on the problems. But then the second thing is also related to problems. And really I try to focus on intersectionality. So looking for problem areas that are experienced by different underrepresented groups in STEM and in physics specifically, and trying to focus on finding solutions together. So yeah, I'm really excited to be on this panel. Thanks for inviting me, and I'm excited to hear about the work and perspectives of the other panelists as well.
Thanks a lot, Summer. Our next panelist is Alba.
Okay, so hi everybody, thanks for joining us today, and thanks to the organizers for inviting me and preparing this panel. So I'm Alba Fernández-Barral, I'm CTO Outreach and Education Coordinator. I'm going to very briefly introduce myself and a bit what we are doing at CTAO. I'm a doctor in astroparticle physics. I've been a researcher until 2018, where I moved 100% to science communication, and lucky me, I could do it in my own field at the Cherenkov Telescope Array Observatory, where I'm leading the global STEAM education program, outreach efforts. Also, I'm coordinated the International CTA Outreach Committee with representatives for all the countries involved in the project. And this committee also includes a couple of sub-working groups for education and diversity. In the later one, we are working to prepare material to bring astronomy to visual impaired people. So actually, when I moved to science communication, it was not a surprise to anybody that actually knew me. I was always very passionate about communication since I was in the school, in the university. I had the need to talk about what I learned in the university. Actually, I did that a lot with my grandmother. I explained to her what superconductivity was. So you can actually imagine how happy I am in this position, and also how patient my grandmother was. So one of the reasons why I moved to science communication, it was because of the social impact that it can have. For me, science communication can help to raise awareness about inequities in science, and we can also be part of the solution. That was the idea too for CTAO. You may know CTAO will be the first ground-based gamma ray observatory. It is a very international project, very diverse, and we are proud of that diversity, and we wanted to promote that diversity along with the science. So we created the Astro Diversity Project. It's in the next slide. Thank you. So the Astro Diversity Project is a project to support and to organize initiatives in the framework of inclusion and diversity. Here you have some of them. I highlight a couple: Women of CTA, which is an annual event to raise awareness about the gender inequity. And also we have some documents like the Code of Conduct for Events and Meetings, and also best practices for colorblind-friendly publication and description. Just some guidelines to make our material, the plots, the description, the captions more available to all our friends. So all the information is on our website. I'm finished here. Let me thank you again, and looking forward to discussing with my colleagues.
Thanks a lot, Alba. Let's move to Srubabati.
Hello, everyone. It's really a pleasure to be in this panel, and I thank the organizers for organizing this important session. I am a senior professor in Physical Research Laboratory from Ahmedabad, India, and I work in theoretical neutrino physics. I am also a member of the India-based Neutrino Observatory collaboration and the DUNE collaboration, and this is my current group. This was, next slide, please. This was not an easy journey, and I faced a serious two-body problem with a small child, and this posed a serious threat on my career. And at one point of time, it was not very sure that I could have a career in physics. And what I realized is that these problems still persist even after 20 years of my time, and many young women are not able to realize their true potential. So this issue is not about individual issue, and it does not get corrected with time. So this motivated some of us to do something about improving the gender climate in Indian physics profession. And as a result of which, the Gender in Physics was established in 2017 under the Indian Physics Association. I was a member of the group, and then I am currently the chair of this group. I also represented India in the International Conference on Women in Physics and in 2017, and this year I was the country team leader. And as a part of our group, we organized a first conference on Gender equity in physics in India in 2019. This is in the line of the International Conference on Women in Physics, the EQUIP conferences. And it received a very good response. And there were many sessions, science sessions and gender sessions, immersive workshops, interaction with social scientists, and the deliberations led to a document called Hyderabad Charter, which is a guiding document for gender equity in India. And what we did was we asked physicists to sign this document, and signing this document means that you take a pledge that you will try to improve the gender climate around you. So, so this is what I am involved in. And thank you very much.
Yes, so I would also like to thank the organizers for inviting me. So I'm Kamiel Janssens. I'm living in Antwerpen, Belgium, the country of chocolate and fries. So very tiny country on the place, but maybe one of our delicious foods. So I'm in my PhD, a combined PhD between the University of Antwerp and Universiteit Côte d'Azur in Nice in the south of France. And I'm working on gravitational waves and more specifically data analysis using data from Virgo, LIGO, and Kagra. I'm looking for a weak signal of stochastic background of gravitational waves. But on the side, in my free time, I like to spend some time on yoga to just relax after a long working day, or do some rock climbing. And I'm also interested in psychology as well. And so that's linked to what's on the next slide. So my main involvement in diversity, equity, and inclusion is related to mental health. I think it's very important that everybody has a good mental health, both in their private life as in their work life. And I hope that we as collaborations or as a group of people in the physics community can make the situations as pleasant as possible for everybody working here to have higher mental health. And so with this focus, we also currently having a mental health survey within the LIGO, Virgo, and Kagra collaborations, focusing on work-life balance, loneliness, depression, and also some diversity, equity, and inclusion. And so here I show one of the very first results, which is a depression indicator. So left, it is very mild. On the right, it's more severe indication for depression. So the pink, it was only 3 people filling in the survey from that group. So it's statistical fluctuation. But yeah, there are still too many people on the too far right sides, I would say. So yeah, I like to try and improve the environment. And if you have any questions, feel free to contact me as well.
Yeah, thanks, Srubabati, because I was mute before. Thanks, Kamiel. Let's go now with Jonas.
Yes, so I'm Jonas Rademacker. I work at LHCb predominantly and at DUNE as well. And my claim to fame regarding equality and diversity is that I was LHCb's early career gender and diversity officer. That was my first role in that, and a true eye-opener. And it was also the first time that such an office was created in the LHC experiments. LHC was doing something new there. And I also then continued with this kind of work at my home university. And so topics that I feel particularly strongly about, one of them is ignorance. So I represent the group of middle-class, middle-aged white men. And we don't experience that much discrimination or harassment, but we need this group of people on our side in order to improve the situation. And one aspect of that, I think that's very important, is information. I'm a great fan of surveys, make surveys, for example, also in your group, because I hear very often, yes, harassment is a really bad problem, but it doesn't exist in our experiment or in our school. And of course it does. And the majority of women experience it at some point in their lives, and the third at work. Another topic, and that was actually touched on indirectly in the previous 2 presentations, is our appalling career structure, because it's not good for our mental health. It's not good for fathers or mothers, but because women are more often the carers than men, it also is a gender issue. A career structure where you have no job security if you ever get it until you're about 40. And where you have to travel through different countries. And then one of the most overlooked, I think, but the most important aspects of discrimination is socioeconomic background. That is certainly the case for access to university education. And of course, if people don't get university education, then we don't see them in our field as particle physicists or astrophysicists. And the next slide, I have a second one. That is, I didn't say which university I was on. I think it's the University of Bristol. And there, if you look very carefully, you can see, and I think I might be able to annotate this. You can see this thing there that is meant to be a fish, and that's the same as here. It's actually not really a fish, it's meant to be a dolphin, but at the time they couldn't really draw dolphins properly, so that's a fish. And that's the same as the one that you can see here. And on top of that, that is Mr. Colston, and he got the honor of having his dolphin in our university crest because he donated a huge sum of money to the predecessor of Bristol University. And he made most of that money through the slave trade. And his statue has been standing in the center of Bristol for many, many years, until at some point the people of Bristol had enough and he had to take a bath in the Bristol Harbor, which is here. And that's all from me.
Thanks a lot, Jonas. Let's go with our last panelist, Maggie, please.
So I will once more thank the panelists, the organizers for giving me this opportunity and having such commitment to these topics. And also want to thank Ines for doing a great job of keeping us to time because we probably each of us could speak for hours on any one of these topics. So I'm mainly Sanchez. I'm a professor of physics and astronomy at Iowa State University in the United States. And I'm also co-chair for equity, diversity, and inclusion in the NOVA experiment, which is perhaps the hat that I'm here with. I work in experimental neutrino physics. I work in 3 experiments of, and you can see it's sort of a range of sizes. I'm co-spokesperson for this AN experiment, which is an experiment of sort of tens of people, 30 to 40 people. I've had various leadership positions within the NOVA experiment. In particular, I most recently co-chaired this what we call EDI group. And I'm also on Dune as well, which is an experiment of, sort of on the order of 1,000 people. So those are very different experiences, and we can talk a little bit about that later. I also mentor women and other gender minority undergraduates at my institution through the Society of Women in Physics and Astronomy, which I'm a mentor for. And I serve as a co-chair, as I said, in the NOVA experiment. I collect the group that developed the code of conduct within the collaboration. So we have some experience with that. I put in a link to the public version of that. It is inspired, in fact, by some other documents coming from as it happens, astroparticle experiments. And when the motivation to do all of this is that when you look around and if you look at the experiences of people, specifically women, but other gender and racial minorities, change is just slower than I would like to see. And so I would like to see change by raising awareness of these issues, by listening to the experiences of those of having the experiences that we need to change, and then translating that to actionable items. And I think with that, Ines, I will give you back the floor.
Thanks a lot. So we have a super diverse panel, which was the purpose of this. So next point on the panel is to go to the discussions among the panelists. So these are the 4 questions that I'm going to raise. Let's start with the first one, which will be answered by every panelist because it's a quite general one. Let me read it. What are the main barriers we face in our field? Here we are talking specifically about astroparticle physics, but also particle physics. How to raise awareness of them, and what are some of the best practices that can be adopted? So let's start with Summer.
Yeah, so I had a really hard time choosing, the main barrier, because I think that in my experience, being someone who, I identify with many, or let's say several marginalized groups in physics, it's like, well, which one do I pick? So I just kind of went with one that I think actually has a pretty wide-reaching impact. It impacts not just women, men, not just LGBT people, also straight people. And that is this business of really short-term contracts and the expectation to move internationally. And I think that this puts a tremendous amount of stress, mental pressure on, in particular, some of the people who are already the most vulnerable in our community. It's extremely difficult to deal with these contracts if you have a family, especially if you're the primary caregiver, but you're also supposed to be applying for jobs every 2 years. It's difficult for members of the LGBT community who don't necessarily feel safe living in every country. And it just puts a lot of undue stress on people. So if I had to choose one, I think that's what I would go with. I think raising awareness, just talking about it. But I think, unfortunately, this is one of those problems that really needs a strong interface with funding agencies and institutions. We need a systemic change. And I think I have not been in the game long enough to know exactly how to do that, how to make that change. Yeah.
Thank you. Alba, would you like to comment?
Yes, I actually agree with Summer. In our field, in science in general, we have several barriers, but I think most of them can be faced through education. One of the reasons I think we have so many barriers is the fact that we have a lot of underrepresented groups, women, LGBT people, people with some impairments, and so on. So the problem is that the issues that these groups have to overcome are kind of hidden. They are not highlighted at the same level as other general problems. Now, that's something that Jonas mentioned already in his presentation. And for me, well, that's the biggest challenge, really understanding these problems, trying to change this underrepresentation. Otherwise, we end up with low percentage of women decision-making positions. We end up with lack of material or even skills to prepare presentation for visually impaired people. We don't have workshops prepared for reduced mobility and so on. So the big challenge ahead of us, from my point of view, is actually to make inclusion an inherent part of science, to make inclusion, to make diversity an integral part of all our projects, scientific projects, science communication projects. And I always said that I think most of us has been educated in respect and in empathy, but I wonder whether we have been educated in inclusion. And I don't think so. And we need to change that for the next generations. The future generations, they need to already think in terms of inclusion, in terms of diversity in a natural way when they are preparing these projects, initiatives, presentations, and so on. And how we do that, how we can change this dynamic that we currently have through education. We, as observatories, institutions, universities, we need to work with the formal education system in order to reach the very early stage students, to work with them from the very beginning. We are already doing that with the gender equity activities and so on. Every year we have more and more activities, and we can see that they are giving positive results. We can see them in the UNESCO reports. Every year we have slowly, but we are improving. So from my point of view, we need to keep doing that, and we need to also apply that to other underrepresented groups in science in our field.
Yeah, inclusion is a very important word. Let's go now with Srubabati perspective. Yeah. We cannot hear you now.
Yeah. So from the Indian perspective, as I said, I find that the major obstacle was the serious underrepresentation of women as we go higher up. The pre-PhD level, the male-female ratio is almost equal, like, it's maybe 45% female. But when one goes to the faculty level, then it turns out to be about 16%, 15-16%. In astroparticle physics, it's little less. So it seems that we are losing a lot of trained, trained women who are not able to continue even because at PhD level, there is about 30% are doing PhD. So, and the two main obstacles that we are seeing is that one is balancing care. Because getting a job takes time, so it interferes with the biological clock. And there is also the two-body problem, getting job in the same space as a spouse. And then as a mostly drop off from a research career. And there is also the issue of bias and discrimination. And often there is a non-serious approach towards long-term career goal of women. So these were the two major obstacles that we found. And then, so in the charter that I mentioned, which came out as a result of the deliberations in our conference, there were definite for institutes, for government agencies, for at the curriculum level, so that at the basic level we start including diversity and inclusion in the curriculum. Some of the best practices that were mentioned were awareness program and gender sensitization program, bias training for institutions as well as institutional leaders. Then also gender, because in Indian context, the statistics is not really very much there. So all the statistics, like from our group, we had to collect to find these numbers. Then creating two-body opportunities, that is also very important. And also the hiring policies to be formulated beforehand so that the status of spouse or your caste or background, these things don't make much impact. Like, so it should be decided beforehand. And also one more thing that we stressed was that mentoring of young faculties, because young women or people from marginalized group are seen to face a lot of pressure. So if there can be a mentoring mechanism for them, then that is very good. And fostering women's success and fostering success of minority groups, marginalized categories in terms of role models, and also more women leaders. So these were some suggestions that we made. And one of the promising aspects that we see is that in the past 3 years, the government has been very proactive. There are many schemes, accreditation programs, and especially the new science and technology innovation policy that is proposed in India is very inclusive and is talking about gender going beyond binary. So that way we feel that there is some change which has started to happen in our country. Thank you.
Thank you very much. Kamiel, would you like to answer this question from your perspective?
So something that was already brought up by many people, and I fully agree upon, is ignorance. But I would like to add there are also habits and culture. So often I think we are just unaware that we do actions that might be hurtful or difficult for other people. And so one example that really sticks with me, so one of my close colleagues and good friends is a gay person. And so often when you ask to a woman, you ask, do you have a girlfriend? To a man, you ask, do you have a boyfriend? And it's so basic, but just by switching to ask, do you have a partner? It's gender neutral. And so once he told me that for him, it makes a really big deal, because often either you feel uncomfortable to say, no, I don't have a girlfriend, but I have boyfriends, or otherwise he's forced to lie if he doesn't feel comfortable to come out of it. And it are often even tiny things we can do to change, and we are just unaware of it, how to make it better for everyone. And I think they're just go in conversation with people from other minority groups, people with other backgrounds, to learn how they experience everything, so you can get their point of view and then change accordingly to make it a more pleasant and welcoming environment for everybody.
Thank you. Jonas?
I want to go back a little bit to Summer's point, and also to the matter of career structure and the matter of underrepresentation of various groups, especially women. But in my university, for example, we don't have this. We had just had our first Black lecturer employed at the lowest pay grade that we have. So there are many kinds of underrepresentation of many groups, and very little, I have the impression, is achieved by asking nicely in the world. So therefore, I think a little bit of pressure at the right points, while trying to keep allies and not alienating people that could become allies. A little bit of pressure is quite healthy. So I would encourage, I think in terms of career structure, what we really need is a union-like thing. I do think that early career scientists should get organized and not put up with this crap anymore. I don't think there's any incentive for the funding agencies or the universities to do anything different. In fact, I know that the universities in the UK do whatever they can. The funding agency recently introduced a scheme that would alleviate the problem a little bit, a fellowship that you can get relatively early, and that requires the university to give you a permanent job. They had to abolish that condition because the universities didn't like that. And because they have commitment phobia, these people. So I think it needs pressure. And I think it might need organization from young scientists. Regarding pressure, regarding representation, there's one thing I'd like to share with you, and that's the Athena Swan agenda. That is something in the UK, I believe, only. It has many awkwardnesses and disadvantages, but I have become a fan because of the impact it has had on my institution. It's a label that you can get. So you have to write a rather long application, and it refers in the current state only to gender representation, but it's moving beyond that at the moment. So you write an application, and then you get a label, no label, bronze, silver, gold. The effect is now that there's no university anymore that feels it can get away without having at least the bronze label. And while this doesn't require much, it requires record taking. So our HR department now keeps track of things that it never kept track of because of these applications. And that is quite a significant impact. So we have numbers now available that we never had available. This is, because it's an important feature, these things get discussed in the department. And that put a bit of pressure on the department. For example, since then, it might be a coincidence, we started recruiting more women than we did for a long time. Because we changed our recruitment process in response to this pressure. That's it, a bit of pressure.
Okay, understood, thank you. Before giving the word to Srubabati, let's go to Meili on this question.
Yeah, so the main barriers it's a tricky one, I think, as Summers expressed. So I'm going to speak to one that I think, again, that we're trying to raise awareness of, but even, as we talk, for instance, about women in physics, a good reminder is that any of these problems are, multiplied by a large factor if you're talking about any intersection of marginalized groups, right? So women of color, women, LGBT, all of these things will multiply this type of barriers. And so the thing I want to refer to and start to put on the table is a recent study, just 2019, on female physics undergraduates in the United States. And they report that 3 in 4 female physics undergraduates have experienced some form of gender harassment. That's 3 in 4. That's, you know, large majority. And 1 in 4 of those, it's actual sexual harassment, you know, beyond sexist jokes and making people feel unwelcome. The study is done in a large cohort. It's a large fraction of the undergraduate women in the United States, which is it's an astoundingly large number, and some, you know, even for me, sometimes it comes as a surprise that it is really this bad. So as we're fighting, you know, I think I don't know if Srubabati would you referred to how small the numbers are at the faculty level. Is, you know, or a pipeline. We keep talking about a pipeline. Why is it that we lose people that are capable, that could be contributing to the science? And is you have, you know, this permanent sort of unwelcoming environment this early on in the process. The experiences have a negative impact, as you could read on the report, on the individuals. And it makes the retention just really, really difficult. It is our loss that happens, right? And if you think about, if we were attending TAUP in person, I hope that we, you know, get to do that soon. Take a moment to think that, you know, 3/4 of your junior female scientists around you would have had, you know, cycles in their brain thinking about how to deal with this thing that is happening around them, that is not happening to, I don't know, somebody like Jonas, as he pointed out earlier on. So I think that's really one very obvious barrier. I don't say main barrier, but here is one that we need to tackle. As I said, it's multiplied if you're in some, you know, in intersection of categories. If you're a woman of color, 1 in 5 do not feel safe attending a conference. So that person does not even show up to discuss interesting physics. What can be done? You know, what can be done about this? You know, the attempts, I think, that we're seeing all around the community is, you know, we're trying to build codes of conducts. We codify what is good and abide behavior explicit. We sign, you know, we try to get community buy-in on that. We're trying to establish mechanisms to report, lowering that threshold for people being able to come forward and talk about their experiences. And this can be done in an institutional basis, but it can also be done in an individual basis, right? You as a mentor, you as a professor can signal that you are an ally. And then having the mechanisms to act on those reports is also essential. So I think those are the things that, and perhaps that sort of leads into the next question when we talk about what can be done.
Yeah, thanks a lot. I mean, we mentioned many different topics: education, inclusion, short contracts, career, ignorance, to put more pressure, harassment. I mean, many topics that we can spend 1 hour for each, but it's not possible. I mean, it's a good example of many things and proposals. So now I would like to go to the second question. And for that, I would just address the question to a couple of people. And I would like you please to answer shortly, because we are running out of time. So second question is specifically on our field. I mean, we are using codes of conduct and best practices documents in our collaborations, and also, of course, in conferences in our field of research. Question here is that, are they really effective? I would like Meili to answer first.
Well, the really effective questions, it's really tricky. I do think that having, if you develop a code of conduct and people sign up to it, in whatever form you choose to do that within the conference or the institution. I think that you're, to some extent, you're getting people to buy into a certain contract of behavior, which I think it's important. The other components, I think you have to really work on lowering the threshold of reporting. And I think once you do that, you do, open the gates for people to come forward. And there's many components to it. People do not, people experiencing these problems who do not want to report, for instance, to a potential employer, right? So are these anonymous? Are the people reporting protected enough? I think that's one of the challenge. And then the other challenge is what to do about it. And at the end of the day, that's where that's the most difficult task to execute, and in fact to get buy-in from. What are the consequences of misbehavior, and how do you implement that in, say, a large collaboration which is sort of a loose association of institutions that are possibly in different countries? What are the mechanisms that a group has to have consequences for bad behavior? And so I'm currently of the philosophy, you cannot fix what you do not know. So I think the most of these current version of code of conduct emphasize first, the signing on to principles and the lowering the threshold for reporting. But I think you have much work to do on, getting best practices on how to act when those reports do come forward.
Yeah, Summer?
Yeah, I want to echo quite a lot of what Mele was saying. So I think that it's, of course, it's really important, and it's great that these codes of conduct now start to exist pretty much everywhere. But I think really equally as important as having the code of conduct, it's making sure that for the victims, it's clear and transparent what the processes are. And I think that's what helps lower the bar. Having people that they can consult anonymously, like an ombudsperson available either through your institution, or on IceCube, for example, we have 2 ombudspersons who are trained on the experiment. So in case there's a participating university that doesn't have one, people, at least in IceCube, have somewhere to go. And I think that having someone to just give you guidance and say, this is what's going to happen if you go down these steps, as a victim, it makes it a lot easier to kind of navigate an already very difficult system. So I think making sure that the codes of conduct are easily available, the procedures are transparent, and that there's a system of support built around them for the victims with the victims in mind is really what makes these things effective.
Okay, so let me go quickly to the third question, which is very much on the actuality of the situation because of everyone suffered the COVID pandemic. So the question would be, what lessons have we learned from the COVID pandemic, and what is the impact of the online activities on diversity and inclusion, specifically in astroparticle physics? Alba, would you like to comment?
Sure. With the pandemic, when we move everything to online, I think we've learned different positive and negative lessons. Let me start with some of the positive ones. The most general one that I see is actually that we've learned that science communication is absolutely fundamental. So every time we have a scientific result, we need a good science communication. We need to have clear, concise messages. We need to bring the results to everybody, but we need to adapt the message according to the context, according to our target, and so on. And this does not only apply to the health field. I think this applies perfectly to our field as well. On the other side, another positive lesson that we learned when we move everything to online. We move also the collaboration meetings. We move also the conferences like this one. And I think that allows us to be more inclusive in terms of groups that have limited resources. So for in-person conferences, not all the groups can send the entire group, all the members to participate. Having online events, we open this. We open the possibility to different groups, different researchers to participate, to show their results, to interact with other researchers. So I actually expect, hope in the future that we keep some of these online conferences and collaboration meetings. It's also actually more eco-friendly. But as a negative lesson, especially in outreach, when we move everything to online, I think we realized we were not prepared to bring our field to everybody, especially to hearing impaired people. When we did a lot of streaming events during the lockdown, during still this year, but most of them, they didn't have a sign language interpreter. Most of the cases it happens because of limited resources of the groups, of the budget, and so on. So I think in this case, what we need is to encourage synergies with different, in a multidisciplinary way. We need to work with social scientists. We need to work with inclusive associations and so on, that they are already doing some communication. So trying to find some synergies so we can support each other.
Thank you. Srubabati, would you like to add anything here?
Yeah, I think Alba has brought out all the points very nicely.
Perfect.
But,
yeah.
You know, in India, what I found is that many young mothers told me that they could attend many conferences, which either otherwise they could not have attended. Problems also, you know, you may not be able to travel so often. So that way, you know, if I feel that if there is a hybrid option later also, it may be helpful for inclusive, for the sustainability. So I think that that's all I want to add.
Perfect. So let's move to the last question. How to address the state of the mental health in academia? Do we face higher mental health risk compared to other professions? Let's start with Kamiel.
Yes, so how to address, I think the first stadium is to know what the state of mental health is, and to have these surveys and to get an image of, okay, this is how mental health is in academia, particle physics, in astroparticle physics, or wherever you're working. So that's the first step. And then it's really looking at which are the major issues showing up. And so a couple of issues that we are discovering now when having the survey within the gravitational wave communities, because of you have these large international collaborations, you're scattered across the world, and you have meetings basically at every possible time of day and night, which sometimes can put quite a lot of stress on people, because sometimes you have to be present at certain meetings, but it can interfere with your personal and family life. So I think that's definitely something to keep in our mind. And of course, there is no easy solution, but at least try and find a more optimal solution for more people. And another issue is that we always have this pressure to make your data public as soon as possible, get all your results out as soon as possible. But this means there are sometimes unrealistic deadlines, putting a lot of pressure and stress on many people. So I think as collaborations, we also should say to the outer community, no, we keep our data. We don't make it public so soon, but we wait a little bit longer so we can process everything ourselves first and get all results out at a comfortable base and not putting too much pressure on everybody, analyzing and so on. And if we face higher mental health risk compared to other professions, Yeah, it's hard to answer at this moment yet. I hope to have an answer in the near future when our survey in gravitational waves, at least, gives us a better view on this. So yeah, also here surveys fit in perfectly, but maybe someone else can chime in.
Yeah, Summer, very briefly, you would like to add anything?
Yeah, so I can also echo that the need for more surveys and also participation in surveys. I know that we're all very busy all the time, but it's really important to take the time to participate. A lot more work needs to be done in gathering this data. At least from my knowledge, there already is some research done, and from what I could find, people in academia are about 6 times more likely to experience anxiety and depression. 6 times. And again, this is one of those things that I think really combines with, or rather multiplies with minority groups, people of color, LGBTQ, women, caregivers, people who already don't feel included and in fact continue to face barriers to just belonging in the field, are at an even higher risk of experiencing mental health issues. And I think, what can we do aside from just collecting more data and trying very hard to convince the people with the power that there is a problem that I think, many of us sort of feel that there is, but maybe the data isn't quite there or convincing enough. I think one thing we can do is just normalize discussions around mental health. So something I do within my own group meetings is at the beginning of every meeting, we go around the table and I say, how are people feeling? What's something that inspired you this week? And I do that before I ask them for plots and results. I take care that I care as much about the people around me who are doing physics as I do about the physics that they're doing. And I think if all of us start to think in that way just a little bit more, reach out to people, especially those around us who are the most vulnerable, we can already start to make the situation better. And then finally, I think that what we need to do is make sure that there is support and it's there and it's clear, and that every institution, every university says, if you need mental health services, this is where you go. And you make it clear from day one, and you normalize it, and you don't build shame around the idea that you might need time off because you're experiencing mental health issues. And yeah, that's all I have to say.
Thank you, Jonas. I will go back to you, but let's now open the time for the audience to get comments and questions addressed to any member of our panel or the comments. Actually, I see one comment from Espectador Anónimo. I think it's Jose Bosch or someone else. Marian, can you confirm?
Yeah, I have the same. I have anonymous as well. I really don't know. Please use your name to ask questions.
Yeah, in any case, the comment is I would like to ask all of you to please remember to use every letter that means LGBTIAQ+. For sure, this is a panel of inclusion. I think everyone, any member would like to comment on this comment?
Thank you for calling us out on it. And yeah, we should try to do better.
Perfect. Any other comment or question from the audience? I don't know, Jose, if you please write your question or comment on the chat, we can address that. Otherwise, I would like to, sorry, I don't understand. Mariam, could you please understand with Jose what is this comment? I would like to go back to Jonas because I think he had a comment on.
Yes, it was just to add a little bit to Summer's comments on mental health, which I liked very much. I think the other thing that we should start normalizing is a healthy work culture. And healthy work culture means not boasting with your 12-hour days, 7 days a week. Ideally trying to avoid that. I find this sometimes difficult, it's not always possible, but I think we should try to normalize a 5-day week with a proper weekend. And normal rational expectations in terms of the amount of work that the student, a postdoc, and the professor can do.
Okay. Time to the audience to make comments. I think we have another one from Maria Antonova. Do you expect any of the mentioned problems to be possibly resolved in any nearest future, or we are still in the very beginning of the way? This is a very general question. I mean, she refers to anything. So please, Kamiel, and then Jonas.
We are in the very beginning. Look at the, come to Bristol, look at the faculty, and you'll see that we are in the very beginning, I think.
Kamiel?
So, yeah, I would like to add that one could even wonder if it's ever going to be solved, and I think it's a never-ending journey, and we always have to try our uttermost best and involve more and more people, but it will always be a journey on which every one of us has to learn and do better and try to do our best.
Yeah, it's not true that we need to find ways to push for that, because I mean, it's clear that we were talking about that to make about little pressure. Gentle manners are not always the best effective. So, I mean, let me just go to another question from Madeleine Zurowski. Do any of you worry about the fact that often EDI efforts are pioneered by minorities, which can place additional time and stress on those already at risk of disadvantage? How can we address or avoid this? That's a very important question. Mainly, Summer, yeah, mainly.
Yeah, I think it's very true that, it's many times the minorities leading the way. I think one should be aware of that and not impose, whenever I bring in to whatever working group, somebody who, is of a marginalized group, I always ask them if they, want to do it and give them an opportunity of a way out. So if you're in a leadership position, I think that's an important one to do. I think the other thing is we need to recruit allies, right? And so having people that are, recognize the problem and are interested in fighting for the change, it's important. From the point of view of the community, I'll say one more thing. Many times the person doing the advocating, might not have all of the elements, might not have all of the experiences, might make a mistake. Recognizing the good intentions in people, even when they're making a mistake, it's also really important. Let's not alienate our allies. I think there's a lot of people out there willing to do the work. And I think bringing them in and finding, things that you can collaborate with, it's really important. And so I am always pretty grateful. To some extent, the allies can speak to certain fractions of the field in ways that people might relate to better and increase the number of people willing to at least recognize the problem.
Summer?
Yeah, so I just wanted to say one thing that's, yes, it definitely is an extra burden to carry. What I do appreciate is that I do feel, and this goes back a bit to the last question that was answered as well, I do feel that there is a bit of a cultural change happening where I'm actively being asked in my funding applications or my job interviews when I was doing that recently to talk about this work that I do and to highlight it. And I do feel like it actually is appreciated, the time that's being spent. And people do recognize that it is people are beginning to recognize that it is as important as doing good research. So that's just sort of, I think I tell myself that whenever I start to feel burned out or exhausted, and it tends to help.
Jonas?
Just to add one example, how some of this can be compensated. Of course, it doesn't always work, but in my university, in my school of physics, we have a workload allocation model that counts, it gives you points or hours for all the dreadful committee work you have to do, and the teaching and the filling in forms. And there, this kind of work is recognized. That's also fairly new. And that has been great progress. So if you are the equality and diversity officer, or if you organize the women in the School of Physics group, you get the hours you spend get recognized in that. And so you have to lower your teaching load. This doesn't help postdocs, by the way, because they don't really have this model, but it's better than nothing.
Yeah, sorry, I think we need to finish. Let me just read a comment from Elena Pinetti. Thank you for the nice discussion, and encourage every woman in the audience to have a look at the Supernova Foundation, an amazing mentoring program for women in physics. As a mentee, I'm really enjoying being part of this community. Thank you, Elena, for your comment. And I need to, unfortunately, to close this open discussion and then go to the concluding remarks. I would like to ask every panelist to say the final sentence to conclude this nice panel. Let's start with Summer, please.
Sorry, I was reading a comment in the chat. So something that I've started doing, and this is for people who want to get involved in the work and also people who are already doing the work. Decide how much time you want to spend on this topic. Is it 1% of your time, 2% of your time? Is it 10%? And think about how much time that is, and set a Slack reminder. Put it in your Google Calendar, set an alarm on your phone as a recurring thing every month. Read a book, an article, a paper, talk to a colleague about these topics, join a support group. It can be anything that you feel comfortable with and that you have the time for, depending on how much you set aside. And I think that it, at least for me, this has helped me do more, get more done. And it's also helped me not do too much and not get too burned out when I feel like things aren't really changing, because I can look at things and say, no, I did something this week or this month or whatever. So I think that's something everyone can do.
Thank you. Alba?
Yeah, I would like to finish with a positive message for our audience, that is that we are all learning, we are all evolving, all the panelists here, all the people in the audience. So don't be afraid to ask, don't be afraid to contact any group that is doing an initiative that you might be interested. Be proactive. No, that it's part of also the answer that we've been asked. And if you want to create a project in inclusion, in diversity, I would recommend a couple of things. The first one that sometimes looks obvious, but it's not, is that you need to involve your target during the creation process. So if you are doing an activity for visually impaired people, you need to create the material with astronomers that has a visual impairment. And the second recommendation is to make public everything you do, the documents, the initiatives, the software, and so on. I think we now are moving to open source science, but this is especially important for inclusion. At the end, I don't think our goal is to be the more inclusive group. Our goal is to make science inclusive. So let's open all the material and make easier for other groups to bring astronomy, astroparticle physics to everybody.
Thanks, Alba. Srubabati, please.
Yeah, you know, before I make my comment, I just wanted to make a small comment to Jonas that the accreditation program in the line of Athena's one from this year. So that was one of the initiatives they took. And as a closing comment, I really want to know many of the rules, many of the things are made keeping men in mind, and they are not like, for instance, age limit and other things. So actually the system has to change. It's not that one has to fix the women. So one has to go from that attitude. And of course, this I am talking about gender as a binary. And as far as other minority groups are concerned in India, the women's issue has still got some attention, but the other issues still need a lot of attention. And finally, I really look forward to a time when gender is a non-issue and we don't have to organize such panel discussions. Thank you.
Thank you very much, Kamiel.
Yes, so I'm just also joining Summer. So I also started with ignorance, and I think knowledge is the key. So learn, interact with people from minorities, people who have suffered being minoritized, and contact them and have these discussions either online, reading opinions, reading papers, reading anything to learn more, so you can adjust your behavior. And also don't be afraid to make mistakes, because we're all learning, and we will make those mistakes for sure. And then you also don't have to judge yourself too hard for it if you just try to do better next time. Always just try to be better next time.
Thank you very much, Jonas.
In addition to that, and to do a survey in your institute, in addition to that, normalize human-friendly working conditions.
Excellent, thank you. Meili.
Yeah, I think I want to amplify what Kamiel said. If I could give people some homework, I mentioned a paper on the gender harassment by undergraduate female physicists, but there are reports in the UK, there are reports by the National Academies of Science and Engineering and Medicine in the US. Srubabati showed one also from India. So look at your environment and look for the information. Just become aware. It's, I think, the message. That's a step number one. Find a group of people that want to work with. I think what at our institution, the Society of Women in Physics, very quickly decided that you didn't have to be a woman to be in the group, that the group is stronger by having allies on it. And I think it was a really important lesson for all of us, is that it is not just on the marginalized minority. So if you're not one of them, become an ally. I think that's really the message.
Awesome. Thank you very much to our panelists for having shared their time with us and sharing their experiences. Has been really an awesome panel. We are very happy with that. And apologies, Jose Valle, for being late. The floor is yours now. Thank you very much.
Thank you. It is a pleasure for me to welcome Nicolao Fornengo. Nicolao comes from one of the most important astroparticle groups in Italy, in Torino. I believe he started by Srubabati. And at the end of the last millennium, he has been attracted by the high profile of our institute in the field of astroparticle physics, and he came to IFIC as a postdoc, after which he, I believe, went back directly to rejoin the Torino group, where he is now one of the leading persons. So I'm very happy to welcome Nicolao for his concluding remarks.
Thank you very much, Jose, also for your very kind words. Yes, I was postdocs in Valencia, now already many years ago. And I would have liked to be able to come back for this TAUP event, but unfortunately, the pandemic made this impossible. But I'm very happy to have a final words on behalf of the steering committee of TAUP conferences to thank you all for the incredible work you have done to set up this first TAUP fully online meeting. This is the first time that we actually have an online conference for TAUP. And this actually, we didn't choose that, of course, but we were forced to do that. And this actually posed a number of difficulties because, first of all, a conference like TAUP, which is very big and gathers people from all over the world, is a wonderful way to meet colleagues from everywhere and to have chances also to talk in person. This was not possible this time. And of course, we all hope that it will be possible in the future. But this also was a lot of complications for the organizers because I was in contact clearly with the local organizers, and they made an incredible effort because they, for a long time, tried to work on an option of a double conference, no? I mean, online plus in person if possible. This was not possible at some point, and they were able very quickly to reorganize everything and set up what we have seen this week, which I think is really remarkable. Of course, will not go through the science of the conference because we were able to see that in this week. I will just give you some final and summary numbers and figures just to have a feeling of what have been TAUP this year. And here we can see that actually the organization was done in a way to have live events and pre-recorded events with live discussion afterwards in order to be able to maximize the opportunity for everybody. So the plenary talks were 29, and we also had two, I would say, very nice tribute talks today for Professor Toshiba and Professor Bilenti, to remember them as very good friends and outstanding colleagues. And I think the organizer made a very good decision to host, this is the first time that it's done in TAUP, to host a panel we just attended on diversity and inclusion in astroparticle physics. I thank them for this. It's a very good thing, in my opinion. And I also thank all the panelists for the very interesting and important discussion we had this afternoon. The number of parallel sessions altogether was really remarkable, and it's very large, 31, with almost 300 contributed talks. Everything was pre-recorded, and then, as you saw, we had live discussion. This poses a very large complexity in the organization. A very large number of posters, also more than 100, and there was a public outreach talk which was held in Valencia in presence with an attendance, very large attendance. Moreover, in COVID times, 160 people is really a great achievement. The number of the registered participants is the largest ever. It's more than 1,000 people, colleagues from all over the world. Here there is a geographical distribution, which is half from Europe, and some people share from the American continent and Asia, Oceania, and some smaller attendance from Africa. And the largest share of this 1,000 participants actually accessed the virtual venue online. So this is a really very large attendance, which also testifies that TAUP is actually not only well known, but also sharing all around the world the increase in activities in astroparticle physics. I also have to mention, I mean, I'm happy, actually glad to mention that the organizers made a very outstanding, they obtained a very outstanding result in caring about the gender distribution, both for the plenary talks and the organization of the co-organizing committee and the convener committee. So almost half are from the female gender and half from the male gender. So this is a very large share for a typical conference, which I think it's very important too. The scientific program follows the line of the TAUP conference, and these are the topics that are typically covered by TAUP. And I'm also glad to underline that there was, again, in TAUP, a session on outreach and education, which is very important because it's also important that we, every once in a while, sit down and talk about how to communicate what we are doing with the younger generations and with people in general. This was actually a very well-organized and with many talks session. So everything was, of course, done by people. So I will not have time to read all the names, but I want, as I said, on behalf of the organizer of the steering committee of the conferences, to thank really a lot all the organization people. So our co-chair, Sergio Pastore, Mariam Tortola, and all the other colleagues and friends from the organizing committee, and they actually cover many institutions in Spain, like IFIT in Valencia, Santiago de Compostela, Granada, Zaragoza, the University of Valencia, CIEMAT and IFT in Madrid, and also Alcalá, the University of Alcalá de Henares and the Illes Baleares. So it was a very wide and very well, very well set up organizing committee, and as I already said many times, they did a wonderful work. A good thank also to the International Advisory Committee who helped in setting up the program, in shaping the program and suggesting topics and name of speakers. It's very wide, so I don't read all the names. And also the great work done by the parallel session conveners for all the different topics covered by the TAUP conference. I think that the parallel sessions were actually quite interesting because they really show the advancement in the field together, of course, with the plenary talks, which actually show on a wider and more general level how astroparticle physics is improving from one year to the other. I spent some time to look back to the last TAUP conferences. It's really nice to see how the field is growing and how many new things were presented in Valencia conference. And finally, I wanted to thank a lot all the people who worked in a sense behind the scenes. We have not seen them because we are not in Valencia, but they did incredible work in making, in having everything working properly. So in this case, I want to list their names. So Sergio Alves, Rebecca Beltran, Salvador Centelles, Valentina de Romeri, Pablo Escribano, Sanjoy Mandal, Pablo Martinez Miravet, Omar Medina, Omar Miranda, Susana Molina Sedgwick, Juan Palacios, Miguel Puerta, and Mario Reg. A big thank to them too, because we have not seen them on the screen, but they were behind the screen, so they did a really incredible work. Not to be able to be physically present in Valencia was clearly a drawback and an unfortunate situation, but on the other hand, since everything was recorded, we have a legacy which will remain. So I list in here the Indico page where all the slides can be found, and the YouTube channel. This is also the first time that you have a TAUP YouTube channel. We might even think about doing something in the future where all the videos can be seen even after the conference is ending now. So again, a big thank to everybody. The conference is actually completed, and the last thing that remains to be done from my side is to announce the next venue. So the next TAUP in 2023 will be hosted in Vienna It will happen from August 28th to September the 1st, and will be chaired by Jochen Schick from HEFI. The organizing institutions are the Comenius University in Bratislava, the University of Innsbruck, the Institute of High Energy Physics in Wien, HEFI, the Technical University in Wien, and the University of Wien. So I conclude here by saying a big thank to the organizers of TAUP 2021 and to now giving the space for the next organization to Vienna friends, and I hope to see you in presence or in 2 years from now in Vienna. Thank you very much.
Thank you, Nicolao, for a very, very nice summary of what the organization of the conference was. I hated to call this a closing session because we as scientists, we are always on the move. And we know that the show must go on, and you have just indicated where it will go on. It will go on in Wien, where we hope to fulfill the next step to many of the challenges that were put in this conference. So I think it is my task to ask everybody to join in a round of applause the beautiful organization of the local team led by Marian Tortola and Sergio Pastor. Not only they were able to make a very, very nice conference, they were also able to innovate. For example, I was really touched by this panel on diversity. I think it is something that whose experience we should learn for the future. And maybe I can even repeat the words of a very famous Spanish poet, Antonio Machado: "Caminante no hay camino, se hace camino al andar." And this experience perhaps shows us the next step of enriching the experience of this conference, which may be perhaps followed by other conferences in the field of particle physics. So let us give a big hand of applause to the local organizers, not forgetting that this is a huge effort, which is to a large extent, it is artisanal and will not work without the generous effort of all the graduate students and postdocs, which Nicolao has listed, and without which we will not have had the beautiful conference we have had. And of course, we should also remember that we had, maybe Sergio can add, financial support from different sources, and also the administrative support of ADEIT at the University of Valencia. To all of you, thank you very much, and let us meet next time. See you, all of you, in 2023 in Austria. Thank you very much.
Ciao.
Thank you, Nicolao and Jose. Thank you, everybody.
Thank you all. Bye-bye.
Bye-bye. See you in Vienna.
And see you next time in
Ciao,
Vienna.
Nicolao.
Yeah, we hope
Ciao.
so. Ciao. Bye-bye.